All right, today we're going to be modeling with quadratic functions. We're going to have graphs and we're going to find the function given those graphs. All right, so let's look at the first one. It says the graph shows the parabola path of a person throwing their keys to another person where y is the height in inches and x is the horizontal distance traveled in inches. Write an equation of the parabola. The keys land 60 inches from the thrower. What is the height of the person's hand catching? Okay, so let's do the first part first. Write an equation of the parabola. All right, so here, notice we're given the vertex. So vertex, and we're given the x-intercept, the y-intercept. So when you're given the y-intercept and the vertex, what you want to do is you want to plug that into the original function. Okay, so we have y, the vertex form, y equals a times x minus h squared plus k. All right, now let's label. Okay, and I'll just label over here if that's okay. Remember, our vertex is always h, comma, k. So our h is, I'll put it here. Our h is 25, k is 80, and they give us the y-intercept. The y-intercept is going to be our x and our y. So we're putting a known x and a known y on the parabola. So x equals 0 and y equals 60. Now we're just going to use those to find a. Okay, because that's the only variable we don't have. So let's plug those in. 60 in for y. A we don't know. X is 0 minus our h is 25 squared plus our k is 80. And here, 0 minus, now we're going to simplify. So 0 minus 25 is negative 25 squared, and I believe that is going to give us 625. Yeah, okay, good. Oops, sorry. So we have 625, 60 equals 625, and it's positive because when you square any number, it becomes positive. 625a plus 80. Now we're going to solve for a, so we're going to subtract 80 from both sides. Okay, that becomes a negative 20 here. 625 times a, and we need to get rid of that times 625, so the opposite of multiplying is dividing. 625, and now we use our trusty calculator to do this one. 20 divided by 625, and it's a negative 0.032. So negative 0.032 is our a, and that makes sense because it is opening down, so our a should be negative. Okay, so we have, now we're going to plug that a into the original function. And we want to leave the y and the x as a y and an x this time. So y equals negative 0.032, and then times the quantity of 8x minus our h was 25 squared plus, and our k is 80. Ta-da! That's our function. All right. And here it says the keys land 60 inches from the thrower. So that's the horizontal distance, right? What is the height of the person's hand catching it? So the height of the person throwing it, the height of their hand is 60. That's when they release the keys. And then So 60 inches, so 5 feet, and then it lands up to this point. Okay, so the person looks like they're going to be shorter, or the hand is going to be lower. So what we do is we take our equation that we just got, y equals negative 0.032 times the quantity of x minus 25 squared plus 80. And we want to use what they told us. X is 60 this time. Okay, so x is 60. So we're going to plug in 60 for x. And now it's just calculations. So 60 minus 25. That's going to give us 60 minus 30 would be 30. So this is going to be 35 squared 80. So we need to do, let's just do it all at once. So 35 squared is going to be 1225 times 0.032, so don't do the negative yet. So 0.032, and put that negative, there you go. And then it equals, and then plus 80 equals, what does that say? 40.8. Looks good. So y equals 40.8 inches. All right. And that looks about right. Okay, so the next one, it says a bird makes a parabola when diving in the water, where x is the horizontal distance in feet, and y the height in feet. Write a function to model the parabola. What's the lowest the bird goes? So we're looking for the minimum value there. And b, what's the average rate of change in height over the time the bird is descending? So the average, the bird is going down. So here we're not given the vertex this time. We're given two x-intercepts. Okay, so we're given an x-intercept and an x-intercept, and we're given the y-intercept this again. Okay, so we're given a point, y-intercept, and x-intercept, two x-intercepts. So let's do it. This one we need the x-intercept form. Okay, so that's going to be y equals a times x minus p times x minus q. All right, and let's label. I should have labeled before. All right, so here our y-intercept, we have x and y again, just like the last example. And let's write that down, x equals 0, y equals 20. Here, our first x-intercept, that's going to be our p. So our p is 1. And we have our second x-intercept, that's going to be our q. So q equals 5. And we just plug those in and find a again. So y is 20, a is a, x is 0, minus 1 times 0 minus 5. And there we get 20 equals a times negative 1 times negative 5. And negative 1 times negative 5 is going to give us positive 5. So we have 5a equals 20. Divide both sides by 5. We get a equals 4. Ta-da! All right, so a equals 4. Now we can plug that into that formula. Y equals, remember the x and the y stay the same when you want the formula, or when you want the function. y equals 4 times x minus, and everything else is what you see there. 1 times x minus our q is 5. Ta-da! Right. Oh, sorry, this is a. And we also need the lowest point. Okay, so we're looking for the vertex. So to do this, all right, we need to find the vertex. How do we find the vertex of, how do we find the vertex of a vertex form? We did that in one of the previous video. You want to take the P and the Q. So, and we take the average of those two, okay? So the average, or the x of the vertex, the x of the vertex is P plus Q divided by 2. So we add them and divide it by 2. So 1 plus 5 divided by 2 is 6 divided by 2, which is 3. All right, there's our x to the vertex. Now to find the y, we just plug that into the equation. Y equals 4 times 3 minus 1 times 3 minus 5. 3 minus 1 is 2. 3 minus 5 is negative 2. So 4 times 2 is 8 times negative 2 is going to be negative 16. So y equals negative 16. Ta-da! So negative 16, what was this? Feet? I didn't label. All right, let's say feet. That's A. Okay, so that's A. Now, B, it says what's the average rate of change in height over the time the bird is descending? So we're just looking at this part from here to here. Now this, we need to know that this is the vertex 3, negative 16. All right, so we're basically imagining this is a line right here, and we're finding the average rate of change. So from here to here, we're basically finding the slope. Okay, so that's gonna be, I'll just put m equals, it's gonna be y2 minus y1 over x2 minus x1. And remember, we go from left to right, so this is our x1 and y1. This is our x2 and y2. So y2 is negative 16 minus our y1 is 20 over x2 is 3 minus, oops, why did I put a plus? Minus our x1 is 0. So negative 16 minus 20 is going to give us negative 36 divided by 3, and that gives us negative 12. And that makes sense because it is going down, so it is a negative. It goes down 12 to the right one each time. Okay, that's it.